Hi guys, welcome to the video. So today we will solve one more LeetCode question. So this question is a valid anagram. This is question number 242. Okay, we will solve it in Java. The algorithm you can use in any other programming language as well. Okay, so let's first read the problem statement. So here, given two strings s and t, returns true if t is an anagram of s and false otherwise. So here we will be given two string. If you see here the method signature, we have two inputs as a string s and string t. Okay, and we need to return whether s is an anagram of t or not. So now what is an anagram? So it is written over here. An anagram is a word or a phrase performed by rearranging the letters of different word or phrase, typically using all the original letters at once. So how can we define it? So if you see here, I will take it these two examples. So first, so it has been mentioned is this anagram which has anagram. If you see T, it also has the same words, but it is rearranged, okay, or it is reshuffled. So if you see here, we have 1 2 3 3 A's, right? Here also 1 2 3 A's. N is over here is 1, here is it is also 1. G is 1, so here also G is 1, and M is 1, and here also M is 1. So it is of same length and it has same numbers of same numbers of letters and the same number. This is the anagram of each other. Okay, now if you see over here rat and cat, so R is not present in this, so it is look at the constraint over here. Many people omit it, but it helps to resolve the questions much better. So if you see over here, the s dot length and t dot length will always be greater than equal to 1, so we don't have to do the null checks, right? And it will be lesser than 5 10 to the power 4. Okay, and one more constraint or assumption is there, like s and t will consist of only the lowercase English letters. So this makes you don't have to check for like lower cases or ignore the cases, so capital letters. So these all things will be omitted. Okay, if you wouldn't have read this line, we would have to do the corner cases, many corner cases, right? So we got the gist of this. Now we need to solve it. So what is the solution for this? So there are many solutions. So one of the brute force solution, or the very basic solution, is like you sort the array or you sort this letter. So once you sort it, if you can compare for each letter, like if they are equal, then they are anagram. So but the problem for this solution is once you sort it, you are using a sorting algorithm, so its complexity will become n log n. Okay, so but this question can be done in O of n complexity as well, so we will try that. Okay, now the second solution is like you can use hash map with that. You can just throw the hash map, you can count the number of letters you have in these words. You can do that as well. That will also give you a O of n solution, but it is equally good. But I can show you the solution it in much lesser complexity and much lesser space. Start the solution. So first what we need to do, we need to check if they are of unequal length, then there is no hope that it will be anagram. Okay, so we can check that. If s dot length is not equal to t dot length, then return false, right? If length of both the strings are equal, then we can start building on our solution, right? So what we can do, we can create a response array, new int. So we'll have 26. Why we are using here 26? Because we'll not have more than 26 letters. Okay, so if you A to Z is only 26, so we are keeping it at 26. Now we'll have a for loop int I equal to 0, I less than s dot length. So why we are using over here s dot length and not t dot length? It doesn't matter because both the lengths are equal. Okay, we'll do I plus plus. Now we will do response array. So now how we need to traverse it, or how we need to use it. So when you create a response array or any array, it will be by default filled with all zeros. Okay, this is one thing. Okay, and its length is 26, so we'll have 0 to 25, right? Now if you want to execute this, and S or T will always have small case letters. So what we can do, s dot char at I minus A. So what we are doing here, okay, so let me explain you. So we use the array like this, right? We use the array name and we use the indexes, right? I, j, or 0, 1. So we use the indexes. So here how we are using the index. So we are taking out the char at this, sorry, this bracket. Okay, so the character at this point. So suppose if my character is B, okay, the ASCII value of B is I think it is 66. Okay, now when you do that, B minus, so B is the character over here, and when you perform minus with another character, so what it converts your char value to your integer value. Okay, so the result of this will be 1. So in the similar case, when you do A minus A, it will give you 0. Okay, because the ASCII value of this is 66. Now for this it is 65, so it is 65 minus 66 minus 65, it will become 1. So this is one of the useful way where you can convert the character value to your integer values. Okay, you don't have to do parsing and everything. Okay, this is one of the shortcuts. Now, so if, since I told you, right, when you create an integer array, by default all the values will be filled with 0. So now you are accessing one of the location over here, and now you're doing plus plus. So if it is 0 by default, so in the starting it will become plus plus, so it will become 1. It will get updated. Okay, now for every digit we find in S, we will update it. Okay, suppose I'll make the try run. Okay, A N A G R A M. So first we will come over here, right? Now what we are doing, char at I, so 0, it is A. Now we are minus A, so it has become 0, right? Now response of 0 plus plus. Okay, now the response of 0 is 0. Now we are doing plus plus, so it's a shortcut. Now it will become response of 0 will become 1. Okay, now similar for n, we will calculate it and we'll plus, and we'll do the plus plus, so it will become 1. Now again we'll come over here. Now the response of 0 is 1. Now if again we will perform the plus plus operation, it will become 2. Okay, now in the array with for the same location, we'll update and we will, like, for 1 2 3, so for A it will become 3. Suppose for nth operation, whatever it is, so it will become 1. For G, whatever operation it will become 1. For R it will become 1, and for M it will become 1. Okay, so this will be our array of responses when we start incrementing for each letter. Now this is one thing. Now what we will do, response char at T. So if we find the same digits at T, what we will do, we will do minus minus. So let's this as an example. Okay, now the example was Nagaram. Okay, suppose Nagaram. So in this case what will happen, so once encounter n, I'll do the minus minus. Okay, so this was for A. this was for N, this was for G, R, M. So these were the counts for my first one. Now for my second one, N, we encountered N, we will do the minus minus. It will become 0. Now for A, we encountered A, we do the minus minus, it become 2. Now for G, it became minus minus, it becomes 0. For A, again we did minus minus, it become 1. Now for R, it again we do the minus minus, we made 0. For A, we did it again minus minus, it becomes 0. For M, we did the minus minus, it becomes 0, right? So now my array, it's back to 0 0 0 0. Okay, suppose if my this letter is instead of N, if I had G again over here, so now if you come here, now my G is already 0. If you do minus minus, it will become minus 1. Okay, so now if we will check our array, resultant array, if it is not all 0, then it simply means that it's not an anagram, right? So we will do the same thing. Now we will traverse response dot length, okay, I plus plus. We will check if response of I is not equal to 0, return false, right? Now if we come over here, now we need to return by default value. If in any of these cases it does not return, then we can say it's true, right? So let's try to run our base test cases. Okay, it is char at I. Here it will become T. Since the length of S and T are equal, so we can traverse with any length. Okay, okay, so it ran properly. Now I will submit it. Yes, it got submitted. Yeah, that's it for this video. Thank you. We'll see you.